Hello, my name is Brandon, and welcome to the next video in my series on basic statistics. If you're new to the channel, it is great to have you. Welcome. If you're a returning viewer, it is great to have you back. If you like the video, please subscribe, give it a thumbs up, and share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So now that we are introduced, let's go ahead and get started. So in this video, we are going to learn about percentiles, quartiles, quintiles, and deciles, and maybe even floortiles. I don't know. So maybe the first time you heard about the term percentile was when you were sitting in your guidance counselor's office or something and they said, hey, you scored in the 80th percentile on the state math exam. Or maybe you got an exam result in the mail that said you scored in the 73rd percentile on the SAT. So these measures are often used in educational testing, but they are used in other contexts as well. So let's go ahead and dig in and figure out exactly what they are. So exam results. Congratulations! You scored in the 95th percentile on the exam for Stat 102, How to Lie with Statistics. The mean score was 47 out of 100, and the maximum score was a 58 out of 100. So, every student failed. But since you were in the 95th percentile, you failed better than everyone else. So, you suck less. As a prize for being in the 95th percentile, you can now be at the front of the line to retake the course next semester. So, of course, I'm joking, but I'm also using that as an example of what percentiles are and sort of what they are not. So percentiles, quartiles, quintiles, and deciles, etc., are all variations of the same thing. It's locating an observation in a data set. It's like an address in the data set. Observations are always sorted from the smallest, the minimum, to the largest, the maximum. They do not have to be an actual value in the data set. So a percentile value doesn't actually have to be a number in your data. Same thing for a quartile, quintile, etc. All quartiles, quintiles, and deciles are just variants of the same thing, and that is percentiles. So a quartile is a specific type of percentile, as is a quintile and a decile. So once you understand the percentiles, you have everything else. And just to make sure everyone knows, a quartile is the data split into 4 equal parts, a quintile is 5 equal parts, and a decile is 10 equal parts. So percentiles represent the number of values out of the total that are at or below that percentile. So these measures of location are relative. So as we saw on the exam example, scoring in the 95th percentile on an exam does not mean you did well. If everyone else did terribly, you just did less terribly than everyone else. But also, the reverse is true. So you could score in the 10th percentile, but if everyone did exceptionally on the exam, you were just at the bottom of the exceptional people, if that makes sense. They are also used in other calculations and charts and statistics that show us shapes and patterns in our data. So box plots, normal probability plots, and cumulative distribution plots. Now don't worry if you don't know what those are. We're going to get to those in future videos, and actually some of those I talked about in other videos I've done in the past. And of course, they are quoted extensively in popular culture. So academic testing, news stories, financial reports, etc. So let's visualize this. So first, we take all of our data and we sort it from the smallest value, the minimum, to the largest. So you can think of this strip as a piece of paper, and what we have done is written down all of our data values along this strip of paper from smallest to largest. Now to get the 50th percentile, which is also called the median, and remember in my previous video, 1 or 2 back, we talked about what the median is. If you take that strip of paper and you fold it exactly in half, and then you open it, there'll be a crease right down the exact middle. Now, all the numbers to the left of that crease are in the lower 50th percentile or in the first half of the data, and all the numbers on the right-hand side are in the upper 50% of the data. So the median splits our data exactly in half. Now a quartile is very similar. It just splits the data into 4 equal parts. So we call that the 25th percentile or the first quartile, and we call that the 75th percentile or the third quartile. So you can think of taking your piece of paper at the top, folding it in half, that'll give you your median, and then we can fold that in half again to get 4 equal creases in the paper, and all the numbers in the first section are in that first quartile or the first 25% of our data, and then the second 25%, the third 25%, and then the final 25%. So all of our data, median, and then our 3 quartiles. So let's talk about the median just for a second. So here is our data. It is not sorted. So the first thing we have to do is sort it from smallest, the minimum, to the largest, which is the maximum. So we go ahead and do that. And we can see that we have a minimum of $29,500. Again, this is salary data. And then our maximum, observation 12, is $500,000. Now this is fairly straightforward because we have 12 values. So that makes splitting them in half very easy. So the first 6 values are in the bottom half of the data, and the upper 6 values are in the top half of the data. And in the middle, in between 6 and 7, is our 50th percentile or a median. What about the quartile locations? So again, we sort the data, and now we can see that since we have 12 values, we have 3 observations in each quartile. So we can put our arrow there, and then our arrow down here on the right for the third quartile. So you can see that the actual quartile lies in between values in these cases. So the first quartile, or the 25th percentile, lies between the third and fourth observation, or $54,000 and $65,600. So in this case, the first quartile, or the 25th percentile, is not a value in the data. It's an address. It's an address in position, and when we find it out here in a minute, it will be an address we can describe with a number value. Same thing with the 50th percentile. That is going to be between the 6th and 7th observation, and then the third quartile will be between the 9th and 10th observation. So what is our location formula? Again, think of the location as an address in our data set. And here it is. It's not all that complicated. Where L is the location in the sorted data, P is the percentile that we are looking for, and N is the number of observations in our data set. And again, we're going to do examples here in a second. Now, a note about Excel, because I know everyone uses Excel. So, frustratingly, there is more than one version of the percentile formula out there. This is the one that's used most often. This is also what Microsoft Excel uses in the percentile.exe function. Also note that Excel expects a decimal value for the P over 100. So in this example, if we're looking for the 25th percentile, P would be 25. So that's 25 over 100 or 0.25. Excel takes it as 0.25. Now you could put a fraction in the formula if you want, but by default, it expects some sort of decimal between 0 and 1. So location of quartiles. So here is the location of the 25th percentile, which is the first quartile. So 25 over 100 multiplied by the number of observations we have, which is 12 plus 1 equals 3.25. So the location of the 25th percentile, or the first quartile, is 3.25. That is a location. For the median, or the 50th percentile, or the second quartile, it is 6.5. For the third quartile, or the 75th percentile, it is 9.75. And again, those are all locations in our data set. So what about the values that correspond to those locations? So here is the 25th percentile, or the first quartile. It is at the location of 3.25. So it is between the third and fourth sorted observation. For the median, it's 6.5. So it's halfway between observation 6 and observation 7. In the 75th percentile, or the third quartile, is between the 9th and 10th observations. So what about the median? Right there. How do we find the value that is the median? So we can see that the median, or Q2, is halfway between the 6th and 7th values. That's where we get the 0.5 in the 6.5, which are 73,600, that's observation 6, and then 78,000, that's observation 7. So our median, or our 50th percentile, is halfway between those two. So how can we find that out? So luckily, that's pretty straightforward. We go up to 73,600, that's observation 6. Now we want half of the distance up to observation 7, which is 78,800. So we take 73,600 plus 0.5 times the difference between observation 7 and observation 6. That basically gives us the midpoint. So we have 73,600 plus the midpoint between those two values, and we have a value of 76,200. So that is our 50th percentile, our median, or our second quartile, all the same thing. So the median was pretty straightforward, it's halfway between 6 and 7. However, the first quartile is a bit trickier. So here we have our location. So the 25th percentile, or the first quartile, is at location 3.25. So what do? We can see that the first quartile is a quarter of the way, so 0.25, between the third and fourth values, which are 54,000 and 65,600 respectively. So what we can do is apply the same formula or technique we did for the median. So for Q1, we have 54,000, that's in observation 3, plus 0.25, or a quarter of the difference between observations 3 and 4. So 65,600 minus 54,000, then we take a quarter of that difference, we add it to observation 3, and we get a first quartile of 56,900. So third quartile, same pattern. Location is 75th percentile, it's 9.75. So we can see that the third quartile, or Q3, is 3/4 of the way between the 9th and 10th values, which are $91,200 and $94,700 respectively. So we have 91,200, that's observation 9, plus 0.75 of the difference between observation 10, 94,700, minus observation 9, 91,200. And when we do all that out, we have 93,825. So that is our third quartile. So we put it all together, 76,200 for the median, or Q2, and then 93,825 for the third quartile. And notice, none of those values are actually values in the data. They simply represent a specific point in the data, or an address in the data. So how do we interpret these quartiles? So first, for the first quartile, we can say that approximately 1/4, or 25% of workers, have salaries that are at or below $56,900. That's how we say it, that's how we interpret it. For the median, approximately half, or 50% of workers, have salaries that are at or below $76,200. And then for the third quartile, approximately 3/4, or 75% of workers, have salaries that are at or below $93,825. Now we always say approximately here, because remember, each quartile that we found is a location in the data and not an actual value per se that exists in the data set. So we always say approximately when interpreting quartiles. Now what about quintiles and deciles? Remember I said quintiles are the same thing as a quartile, but instead of splitting up into 4 equal parts, we split the data into 5 equal parts, and a decile is 10 equal parts. So for the quintiles, we can see that we can get a location using our formula for each one, and then from that location, we can find our value for the quintile. Same thing for the decile, same process. So remember, we have our location formula, P divided by 100 times n plus 1. We can use that for quartiles, quintiles, deciles, doesn't matter. So for example, in the median, we did that. So 50 over 100 for the median, plus 12 plus 1 is 6.5. That's our location. Same process. For the percentile value, it's always the lower location value plus that location decimal, like for the median it's 0.5, times the upper value minus the lower value, and that gives us the percentile value. So again, just to reiterate, for the 50th percentile, this is how we did that in the previous slides. So plotting quartiles. So if we plot our quartiles on a graph here, I want you to look at just what's inside the box. So what we can see is that our quartiles kind of follow a straight line. Ignore the minimum value over here at 0, ignore the maximum value over here on the right at 1. So just look at the 3 in the middle. So that's Q1, Q2, and Q3. We have a nice straight line that increases at the same rate gradually. What about plotting quintiles? Same thing here. So we have our first quintile, our second, third, and fourth quintile. We can see that inside the box, ignoring everything outside, that in the values there, we have a steady increase from each point going left to right. What about deciles? Same thing here. Now this one is a bit different. We can put our deciles inside the box, but what's going on with this last point over here in the upper right? Why does that one look different than the other decile values inside the box? Well, remember, we had a salary in our data that was $500,000. What happens is that $500,000 salary goes into the formula that finds that 9th decile there on the right. So that large salary distorts our data. Now, basically what we have done in these 3 plots, without really saying it, is we have created an elementary box plot. And that's actually going to be the topic of the next video. So finally, what if we want to find the percentile of a particular value in our data set? So our quartiles and things were values that didn't actually exist in our data set, but we do have 12 values in our data set. What if you would like to know that the percentile of a specific value? Here's the formula for that. So the percentile equals x plus 0.5y divided by n, where x is the number of observations up to, but not including the value you're interested in. So it's called the nth value. So we take all of our data, we sort it from smallest to largest, and then we count up to the value we want the percentile for, but we don't include it. Y is the count of observations equal to the value. Remember, a value can occur more than once in a data set. That's completely possible. But I will say in most data that we deal with in statistics, there's probably only going to be one observation for each value. But of course, it is completely possible that there might be more than one. And n is the number of observations in the data. Then we round up to the next whole number. So let's see this in practice. So let's say we want to know what percentile this 5th observation of $70,400 represents. So here's our formula. Now to do this, it's just some simple algebra. Remember, we count up to that value. So there are 1, 2, 3, 4 values up to, but not including that value. That's where the 4 comes from down here at the bottom. Now the 0.5 is part of our formula. You can see there in the middle. The 1 represents the number of values that have the value of 70,400. There's only 1, so we go ahead and put 1 there. And then 12 is the number of observations, which is n. We go ahead and complete that math. So we have 4.5 divided by 12. That equals 0.375. We round up to the next value. So what we can say is that $70,400 is at the 38th percentile in our data. And what we can say is that 38% of the individuals in our data set had a salary of $70,400 or less. Okay, so that wraps up our tour of percentiles, quartiles, quintiles, and deciles. And I want to stress here that the fundamental idea here is the percentile. A quartile is just a special version of percentile, so is quintiles and deciles. So if you understand percentiles, you can get everything else. So remember, everything else is just an equal splitting of the data into 4ths for quartiles, 5ths for quintiles, and 10ths for deciles. So Thank you very much for watching. I hope you enjoyed the video. Thank you for your time, and I look forward to seeing you again in the next video. Take care. Bye-bye.